Lab 5 pool table. To introduce this lab, the purpose of this lab is to observe an elastic collision in real life and analyze its movement properties in relation to the law of conservation of momentum and energy principles. Some fundamental physics principles we need for this lab are the conservation of momentum, meaning the final momentum equals the initial momentum, kinematics formulas such as the velocity and position update formulas, change in x, and solving for v and v final, the Pythagorean theorem equation, a squared plus b squared equals c squared, and the first and third Newton's laws. This lab covers elastic collisions, meaning the mass of each component does the change, but the transfer of energy affects the movement of the components. To preview the result of this lab, here the white and the blue pool ball weighs the same of 0.1559 kilograms. The collision happened at t equals 1.33 seconds. And so here we're taking a stick and hitting the white ball here shown in black with a force, and that causes the ball to travel 0.406 meters and then collide with the blue ball, causing then those balls to go outward. So the blue ball goes up and to the right, and the black ball goes down and to the right. And here we can see it collides at 0.133 seconds. And here the blue ball doesn't move, it's at rest until the collision. Although it appears as though momentum, therefore energy, was not conserved, the difference in total velocities is accounted for in the energy thermal lost due to the friction between the pool table and the balls. I analyzed the following video on YouTube. And so here we made, based on analyzing this video and the position of the balls in tracker, here we can see this is the horizontal position. So here the blue ball remains at rest until the collision at 1.33 seconds, whereas now the white ball, and they both continue to move horizontally in the positive direction. Here, vertically, again, here is kind of more of like what actually happens, what you see. Both of these are what actually happens, but this is kind of what you observe. Once hit, the blue ball travels up and to the right, black ball travels down and to the left. Based on this data, the total time being 3.267 seconds, we're going to find C and D, the total distance that both the blue and the black or white balls travel after the collision using the Pythagorean theorem and the total distance. Theoretically calculating the energy and momentum here due to the conservation of momentum principle, the mass is negligible, meaning when we factor it out, we can cancel it out. And here the initial conditions are that the velocity of the white ball is 0.3045 meters per second, velocity of blue ball is 0, both have final velocities. Predicted versus observed motion by observing how the initial speed of the white ball after it's hit transfers its energy into the speed of the white ball and blue balls, as well as the energy lost due to friction. We can see that the law of conservation of momentum was conserved. Based on the predicted side, based on just working through the experiment using the law of conservation of momentum, it appears that the energy and momentum is not conserved throughout. Some source of error is human of error and precision with tracking the point mass position in tracker, so making sure it hits exactly at the center of mass. Not having enough information to calculate the actual values of the friction forces and thermal energy. That would be super cool if we were able to do that, but having information such as the coefficient of kinetic friction, we don't have that information, so we can't do that. The exact mass of the pool ball, it's in that range, but I just used 5.5 ounces converted to kilograms. We also assume that the pool table was level. If the white ball weighed more than the blue ball, the mass would not be negligible as seen in the conservation momentum calculations. This would change the effect that the white ball's final initial speeds has on the overall momentum of the system. If it hit with the same force, the initial velocity of the white ball would be less, transferring a lower amount of momentum energy to the blue ball and table surfaces. But because the blue ball would weigh less than the white ball, its final velocity would increase because it actually has to move less mass after colliding. If the collision was inelastic, meaning the components stuck together after the collision or the mass of the components changed, the law of conservation of momentum would still apply, but the setup would look a little bit different, still have final momentum equaling initial momentum, but the final momentum, which actually needs to be switched here. So just to be clear, this is the final momentum and this is the initial momentum. But the final momentum both the balls would become one system. Thank you so much. Have a great day.